Hi, grade 12s. Welcome back to my YouTube channel. My name is Shibambu Nshamulo My Wish. This video, I'm going to be taking you through Newton's laws and forces. That is Physical Sciences Paper 1. So this is a question paper that I took from November 2017. And I hope you're going to enjoy and benefit from this video. And don't forget to like, share the video, and most importantly, to subscribe. So as you know that already in grade 12, you have done this topic for term 1, and this is a topic that is originally done and treated in grade 11. But in grade 12, it's there for examination purposes. So I will not waste time. I'll just go straight to the question and show you how to answer these questions. So let us look at the description statement of the question. So we're told that an 8 kg block P is being pulled by constant force F up a rough inclined plane at an angle of 30 degrees to the horizontal at constant speed. So it is very important, learners, that every time you read a description statement, you need to pick up important words that the examiner has decided to use. So in our case here, we can see that our examiner use the words like rough, inclined surface. So the usage of the word rough, inclined simply means that there is the presence of friction in that particular surface. So I'm going to underline these important words that were used in the descriptive statement. So we'll start with the word rough, and we're saying that this simply means that we've got friction that is present. Okay, so this means that the examiner does not have to tell you directly that in that particular surface that you are dealing with, there is friction. So the examiner can use words like rough, right? And if the examiner say that the surface is smooth, so they're saying that the surface is frictionless. And again, we realize that the examiner wrote the word constant speed using caps or using capital letters. So that is also very important when we're answering these questions. So I'm going to also highlight this one, constant speed. So a learner must know that when the examiner say um, a body or a system is moving at constant speed, they simply meaning that the acceleration of the system is 0 meters per second squared. So the examiner can use words like constant speed, or they say it's a uniform, right? Uniform speed or uniform velocity or constant velocity. So that's what it basically means. And obviously we need to um, check the inclined or the type of surface that we have. Here we're dealing with an inclined surface. So we're going to apply the rules of inclined surface. So the first question that we see here, it's the definition. The first question they want you to state Newton's first law in words. So these definitions are there in the examination guidelines. So each and every learner must make sure that they know how to state this definition. So obviously we're going to start with the first law in words. So this first law in words for 2 marks. It states that an object will remain in its state of motion. It states the state of rest or state of motion unless it is acted upon by, unless acted upon by a non-zero force. So that's what is going to happen. So that's how you state Newton's first law in weights. And this obviously is going to give you 2 marks. So as I said, each and every learner must know how to define or needs to know how to state all the laws of motions, and they need to try by all means necessary to actually state them the way they are in the examination guidelines so that they don't lose marks. So that's how we state Newton's first law in weights. And then the second question, it's the drawing of the free body diagram. And I want to emphasize this. Free body diagrams and definitions, these are stuff that are there in the examination so that learners can score marks. So learners need to capitalize on definitions and also capitalize on free body diagrams because these are free marks, right? So in the drawing of a free body diagram, we're going to check the marks allocated for that particular question. So we see that in this question, the marks allocated is 4 marks. So 4 marks means 4 forces. So you know that in this particular free body diagram, you're going to draw we're going to draw 4 forces because of the back allocation. So it's 1 mark per force. And then we know that in grade 12, the 5 main forces that you are dealing with, right? So out of the 5, you only need to draw 4 in our case. So this is 2.1.2. So if you look at this system, we are dealing with an inclined surface, right? So it is very important that learners try to trace the incline before drawing the free body diagram so that when they draw the normal force, they can make sure that the normal force is perpendicular to the surface. So if learners don't draw the normal force perpendicular to the surface, they stand a chance of being penalized for not drawing the normal force properly. So I've traced the incline there, and then this is the dot for my object. And obviously, I'm going to start with the universal force. This force exists in all objects as long as these objects are on the universe, and that is force of gravity. So, and this one, we know that it acts directly downwards. So this one, we're going to call it gravity or weight. And then now we've got the normal force. So the normal force must be drawn perpendicular to the surface. This is the normal force. That is 2 marks now, right? And obviously, we're going to have a normal force because we have a surface. And then we've got the force that is being applied there. This one, we know it's the applied force, so we can call it force F, right? And then now we've got 3 forces. But this one, which is being applied, you can even name it force applied or just use force F because this is the letter that was used in the equation to represent the force. And then we mentioned that the usage of the word rough simply indicates that in this surface, there is friction present. So it means that the 4th force that we must draw here, it's frictional force. And it is very important that we know the direction of friction, the frictional force. So the direction of friction opposes the motion of an object, or we say it opposes the tendency of an object, right? So it means that if this object is actually being pulled up or it's accelerating up the incline, right? So the frictional force will oppose the tendency of motion of that. Therefore, the frictional force will go down the incline. So this we call it friction. And now we've got 4 forces, meaning that we've got 4 marks for our question. So these are questions that we need to actually capitalize on. So we've got 4 marks in the bag now. And out of these marks, you've got 6 marks. These are free marks. So now let us look at question 2.1.3. That is the main question that I wanted to show you how to answer them. So question 2.1.3, it's a question on, it's an application question. This way you need to calculate the magnitude of force F. So this one is 2.1.3. and this question is worth 5 marks. So probably this was the main question for this question 2. So the examiner again gives you extra information to assist you to solve question 2.1.3. So the examiner is saying that the kinetic frictional force between the block and the surface of the incline is 20.37 newtons. So they're giving you the magnitude of the kinetic frictional force. And guys, whenever you have a question that requires calculation, the first formula that actually needs to come to your mind is the formula for Newton's second law of motion, that is F net equals to ma. So we're going to try and check if this formula for Newton's second law is not going to assist us to solve this question, right? So, and it is very important that learners must know the forces that needs to be part of the F net formula. So the forces that needs to be included in this formula, these are forces that are in line with motion. So if we check our motion here, our motion is moving up the incline. So it's moving along the incline. So this means that for the F net equals to ma formula, we're going to include forces that are in line with the incline, which is in line with the motion, right? So obviously, the forces that are in line with the incline here is going to be force applied. That is what is being asked for, is the force applied, and then frictional force, right? And then there is a third force, which is the component of the weight. Remember, the weight has got two components. It's got the perpendicular component that we call Fg perpendicular, and it has what? The parallel component that we call Fg parallel. So the forces that are going to be part of the F-net formula are the frictional force, the Fg parallel, and the force applied. This is only because these forces are in the same line as the motion. So we're going to write the formula for F net equals to ma. So this will be F net equals to ma. And you must always remember that you are dealing with vectors. And if you're dealing with vectors, it means that you must remember to take one direction as positive. So I prefer taking the direction of motion as positive. So it means that in this case, I'm going to take up the incline as positive. So you need to indicate there so that the marker should know which direction you took as positive. So I take up the incline as positive. So this means that each and every force that is going up the incline is going to be reported as a positive value. So now we start. So we're saying we're going to include the F applied, force F, the frictional force, and the Fg parallel. So it means that based on our choice of direction, the force applied will be positive because it's going up the incline. And then now we're going to have plus, minus, Fk, that is the kinetic frictional force. And the reason why it's negative is because it is going down the incline. And we're going to have plus or minus what? Fg parallel equals to ma. So here we realize that, remember, we said the usage of the word constant speed means that the acceleration of the system is 0. So you know that if the acceleration of the system is 0, therefore the F net for that system will also be 0. So for F net, we might as well write F net equals to 0. That is what we have there. And then all we need to do now is to substitute the values, right? So what I'm going to do here, I'm just going to expand until the last degree, and then I'm going to perform my substitution. So I usually do this so that my work is well presented. So here we're going to have the F applied, which is the unknown. We're going to have minus Fk, and then we're going to have mg sine of theta. So this is the formula to calculate the parallel component of the weight equals to 0. And now that I've expanded until the last degree, what I need to do now is to substitute the values. So force F is unknown, that's what we're looking for. I'm just gonna leave it like that. And then Fk was given on the question by the examiner there. And then remember, they said that the magnitude of the kinetic frictional force between the surface and the object is 20.37. So this is a given value. So I will have to substitute it the way it is there. So where there is Fk, I'm going to substitute, it will be minus 20.37, and then I substitute the mass of the object. The mass of the object is an 8 kg block. So I want us to go back to the question so that we don't make mistakes. The object is an 8 kg block, good. So we're going to have the mass as 8, the g, which is the acceleration due to gravity, it's 9.8, and then sine of theta. So the theta is the angle of inclination, or the angle of the incline. That's sine 30 degrees equals to a 0. And obviously, all these will assist us to get the magnitude of F. So therefore, if you simplify here, you're going to get the magnitude of F as 20.37 minus 20.37 minus 8 times 9.8 sine of 30 degrees. And this is going to give us F equals to minus 59. Sorry, it's not a minus. It's going to give us, because now I'm solving for the unknown F. So this will give us 59.57 newtons, because obviously we're going to carry over everything to the other side of the equation, and that will give us the magnitude of force F. So for performing this calculation, you're going to get 5 marks. And then this question, I'm going to perform it in the next video because I'm trying to keep my videos short. So I hope this video opened your mind on how to approach the Physical Sciences Paper 1 2017 paper. And I hope you enjoy the video. Please don't forget to like, share, and subscribe.